Hello everybody, this is Matt with Technoax Gaming, and I'm going to continue this Electric Universe series by kind of tackling the issue from the other side, because in order for the Electric Universe, if the Electric Universe is true, then that must mean that the other theories, the mainstream theories that we tout right now, is false. So I wanted to kind of put a little bit of thought into basically what's going on right now in the mainstream media, and that is, this is pretty recent too, is that in late 2015 astronomers basically found what they thought is gravitational waves, and they're touting that evidence as proof that the general theory of relativity from Einstein is actually true. So if that is the case, then we don't need to tackle the electric universe anymore, because we already know that Einstein's proof is true, his theory is true, and therefore we can go from there. But there's been some dissenting voices, and most notably from this guy called Hilton Ratcliffe. And just to give you an idea about who he is, I'll read his about section here and you'll see for yourself. Hilton Ratcliffe is a South African born physicist, mathematician, and astronomer. He is a member of both the Astronomical Society of Southern Africa and the Astronomical Society of the Pacific. He became a founding member of the Alternative Cosmology Group, an association of some 700 leading scientists from all corners of the globe, which conducted its inaugural international conference in Portugal in 2005. Okay, so he's got some credentials here. He's basically a physicist and a mathematician and an astronomer, and he's a founding member of a lot of these astronomical societies. And this one right here is really interesting to me, actually, where he's founded a group that includes over 700 leading scientists. So he's got some credentials. So now that we've kind of seen what he's all about, it lends credence to what he's about to say. And I'm going to read this to you and kind of interject little explanations here and there, just to kind of keep everybody on track, and interject my own opinions, because this is my video and stuff like that. And this is kind of like a react series, right? Except I'm reacting to an article, and I'm going to do that right now. All right, so on Thursday, February 2016, a group of some 1,000 scientists co-authored a paper announcing that the LIGO interferometric array had, after more than a decade of fruitlessly accumulating data, positively identified the signature of gravitational waves coming from a deep space event. Okay, this is the thing that they're talking about, where the gravitational waves are what they think is the proof that proves Einstein's theory of relativity. This was a phenomenon predicted by Albert Einstein in 1915 in a landmark paper henceforward known as the general theory of relativity. I have known for some time that the results are being attributed to observations made with instruments that were inherently incapable of doing so. And strangely enough, this is also another argument against the 1919 proof, or the 1990 evidence that was gathered by Eddington to first gain Einstein's acceptance. Einstein's theory of relativity was initially accepted by the scientist community because Eddington went down to, I think it was South America or Africa, and he observed a solar eclipse, and he made some measurements with instruments down there and proved through those measurements, quote unquote, proved that Einstein's theory was correct. And we'll go through that proof another day, but we'll just stick to this one. Just know that this is very similar to the arguments against that proof as well. So anyways, okay. My skepticism was well known, and I consequently received dozens of requests to publish my view of the matter. In general layman's terms, here it is. Okay, on September 14, LIGO observed a chirp lasting about a fifth of a second. Analysis of the signal suggests that it was produced by a cataclysmic collision of two black holes a billion light years away. Question: the almighty collision between two supermassive bodies produces a wave lasting just a fifth of a second? I agree. I mean, picture it, two supermassive black holes. It's a gigantic event in the universe, and we only picked up a fifth of a second of gravitational waves. I mean, that's all it produced. Seems rather underwhelming, given the apocalyptic nature of such an event, you know. Alright, so the instruments that comprise the LIGO, or Laser Interferometer Gravitational Wave Observatory, were set up to try to achieve a specific goal consequent to the predictions of general theory of relativity. Got those? Okay. The mirrors in the interferometer are set 4 kilometers apart. The expected variation in the distance would be 10 to the negative 18 meters, or 10 to the negative 15 power millimeters. In layman's language, they are looking for a change in distance over the 4 kilometer separation of 1,000 trillionth of a millimeter. That's very small. I mean, get out a ruler and see what a millimeter is, and it's hard to comprehend something that's so much smaller than that. But that's what they're expecting right there. That's what they need to basically make this measurement. The change in distance equates to a required design sensitivity of the LIGO interferometer of 1 part in 10 to the 21st power. That is a resolution of 1 part in 1 billion trillion. Let's try to put the expected variation into some sort of comprehensible perspective. The diameter of a hydrogen atom is obtained experimentally at 10 to the negative 7th millimeters. Therefore, LIGO seeks to measure a distance that is 100 millionth of the diameter of a hydrogen atom. That's very small too. Put another way, if the change were 100 million times greater than the one they claim to have measured, it would be the same as adding or subtracting a single hydrogen atom, to or from a 4 kilometer distance separating the mirrors. Okay, so the design sensitivity requirements requires that we have exactly 4 kilometers between the two mirrors, and that the variation cannot exceed something that is much smaller than a hydrogen atom. And I mean, we've come a long ways in terms of being able to have accurate equipment over the decades, but we haven't gotten quite that accurate, and that's for ideal circumstances too. This is for ideal circumstances that we would be able to do that, which we're not able to do that yet, and we're not even accounting for stuff that makes this non-ideal. So anyways, that is probably unimaginable to most, so let's try to add further perspective. Let's do. The best precision mirrors are polished to match the ideal nearly parabolic surface of 25 nanometers, or about 3/10,000ths of a width of a human hair. That is incredibly fine tolerance, but let's compare it with the difference in length that LIGO claims to measure. A nanometer is a unit of spatial measurement that is 10 to the negative 9th meter, which is much bigger, or 1 billionth of a meter. Take it down one level, a nanometer is 1 millionth of a millimeter. The most precisely polished astrophysical mirrors, like the ones used on LIGO, can have peaks 25 nanometers above and below the theoretical surface plane of the mirror. 50 nanometers is a billion times bigger than the gravitational wave signature. In practical terms, it is impossible to measure the distance between the two mirrors in each interferometer, actually said to be 3,999.5 meters, which is a little bit less accurate than what we thought, to the required tolerances. So they've had to make an average. They had to take an average, which is guesswork. Okay. There are other conditions which change the distance between the mirrors by many orders of magnitude greater than the anticipated gravitational wave fluctuations. And this is where this is the thing that really gets both proofs, both the Eddington proof in 1990, especially because we didn't have the tools to make things that accurate back then. But then this affects us now with this one. This piece of evidence being touted as proof. Waves caused by seismic fluctuations, earthquakes and stuff like that, are ever present, disturbing the separation. There are also anthropogenic waves resulting from trucking, blasting, mining, and railroads, for example. Then there are the influence affecting the light and its frequency that lie between the source of the radiation being measured and the Earth. There are all manner of objects, systems, and force fields in the intergalaxian space. These are not precisely known, some are completely invisible to us, yet they have a profound effect on light signals that simply cannot be quantified by measurement. The LIGO instruments have all sorts of protective devices shielding them from extraneous kinetics and noise. But to filter those impediments out without fiddling with the sought-after signal, the LIGO scientists would have to guess their magnitude. That is not an empirically sound way to arrive at an accurate answer. Okay, and so why would they flub this? And the answer is below. Okay, if you really wanted to be honest and be honest about this signal, it's pretty clear throughout this writing right here up until now that if the scientists were honest, they would really recognize the ambiguousness, the claim that they're making is not true, basically. Okay, so, but why would they tout this as proof? Well, the answer is below. LIGO cost over $620 million to construct. Research grants and operating costs take that figure to well over $1 billion. Hold that thought. To summarize, paraphrasing the words of Nobel laureate Steven Weinberg in reference to Edwin Hubble's initial interpretation of Galaxian redshifts, it seems they knew the answer they wanted to get. Right. Okay. So basically what it's saying is the instruments could not have been accurate enough to basically pick up the waves that they thought they did. And the reason why you would lie about that result is because you wanted to keep your funding, because this is an incredibly expensive piece of equipment here, and also incredibly expensive operating costs as well. So if you were wanting to impress government officials, to be able to maintain research grants and keep the money flowing in, trying to tout this as a result to a very fundamental piece of science that we have taken as something that is truth, but in reality it hasn't been proven yet. Like I said in one of my earlier videos, Einstein's theory of relativity is not proving. We have things like GPS satellites that kind of correlate with the results of the theory of relativity, but the relativity theory itself has not been proved. And in terms of GPS satellites, there may be a correlation between what they experience in terms of their slowing down of clock time and Einstein's theory of relativity, but that doesn't necessarily mean causation. So we need to take this with a grain of salt. Also, Eddington's proof, which I'll get to probably at a later video. And I wanted to basically read this to just kind of lay down the ambiguousness and also the fact that we do not have the answers, and sometimes scientists are prone to being wrong and not admitting that they're wrong, instead of taking a logical approach to things and basically analyzing these things honestly. So that is my video. I'm going to come back with more electric universe things. I hope you enjoyed this, and I'll talk to you guys later.